In this video, we're going to be covering idle, which is Python's included IDE, where IDE is, of course, being an integrated development environment. That means we'll have things like an editor and some tools to help us in creating our Python code.
Now, is this an extremely powerful IDE? I mean, myself coming from Visual Studio, I mean, I've got a very robust IDE over there.
I wouldn't say it's as big of a project as many of the larger IDEs because, I mean, those style IDEs, like some of the more well-known ones, including Visual Studio, have been around for a long time and have massive development teams behind them.
I gotcha.
Idle it's a lot more small scale. It is rather powerful in that it makes a very good learning tool. It has a bunch of features that a lot of other Python editors don't have. It actually has autocomplete, word completion. It is somewhat aware of the code that you're working with.
Gotcha. So you said a lot of other Python editors. So there are other IDEs that I can get my hands on for working with Python?
There's a lot of other programs, both editors and IDEs. You can actually make a little bit of a separation between editor and IDE.
Okay.
At least the way I look at it is an editor is purely a text editor. It
Gotcha.
will, at best, allow you to run an external program upon some key binding.
So a Python editor, you're talking about something that's got, you know, colored syntax and stuff like that?
Yeah, I'm basically just saying that, by editor, some program that allows you to edit source files and provides some sort of syntax highlighting.
Gotcha.
And then, other than that, the features generally end there. It doesn't give any kind of debugging information. It's merely just a facility to allow you to create source files.
So with idle, we do get the ability to do debugging, etc.?
Now with idle, you do have IDE features, and I would consider IDE features to be things that give some sort of interactive or otherwise tool to allow you to work on things.
Okay.
These things include things like a debugger, where with the debugger you can set breakpoints in your code, you can look at the stack, you can look at things that exist in the current scope.
Excellent.
So you're given tools to work on not just the source file, but the actual running program at hand.
Okay, cool.
So, of course, we're going to be looking at idle itself. Another interesting point is that idle is actually built in Python.
So it was written with Python.
So you can actually load up all of the source files to it and see how all the extensions work and change all the configuration just from its library directory within the Python install.
Very nice.
Now, to get started, I want to begin with a new source file so we can get idle itself loaded up.
Okay.
What I'm going to do here is I've created a folder on my C drive called Python Projects. I'll just use this as a good working directory for making all of my source files. Now, to make a source file, the way I'm going to approach this is just a workflow that I've become fond of. You can, of course, launch idle from the start menu. As a matter of fact, if I jump over to the program group for Python 2.5, you can see that we can, in fact, launch idle from the start menu.
In fact, why don't you go ahead and do it real quick and just show them in here. If they wanted to start writing a script from in here, how would they go about doing it?
Well, it's interesting you mention that because by default, if you launch from the start menu with the default settings for idle, you will be presented with a Python shell first before you get an actual editor. Because, of course, you're going to use one editor per source file. So if you're editing a large project that had many source files, you may potentially have multiple editors open at the same time. But if you launch from the start menu with default settings, you're of course presented with the shell. If you wish to get to something in which you can edit and save source code, you'll need to go to File, New Window, and this will open up an actual editor window where we can do things like open files, save files, and whatever you want. And I'll get into a little bit of this configuration here in a minute when we start creating files ourselves. Because,
go ahead, sorry.
Because I was just saying, as a personal preference, I do prefer to have the source code load before the shell window. But again, this is just because it's based around how I work on things. If you do a lot of work in the shell, it may be beneficial to have the shell load first.
That's what I was just about to say, and that is that perhaps a lot of people work this way. They simply go in, they launch idle, and then file new or open and continue.
Because it also depends on the kind of project you're working on. If you are going back to a large project, you may want to go to the shell, just load a piece of that project, load up several of its source files and tab through them, or whatever you want. So again, this just being one of a few ways to open up the shell.
So we can go ahead. You want to go ahead and close the shell and just show the way you normally go about starting a project?
Yes, and I was also going to give a quick description of the reason I like working like that is that way I don't have to deal with a bunch of file open dialogues. It's just being another personal preference with working on source in general, is I've grown fond of using the operating system's explorers themselves in order to find things instead of the much smaller open dialogues which hide a lot of things.
Gotcha.
So what I'm going to do is I'm going to close out the Python shell, the idle GUI, and go back to just such a directory. My preferred workflow is just to create any random file, name it .py for the correct extension, and then load that file into a new instance of idle.
Okay.
So to do that, what I would do is I'd actually grab new text document, because of course I haven't gone through the process of adding a new class for Python that appears within the new dialog. I pretty much just use new text document for anything, because to me all that matters is that that is an empty file. I'm not really concerned what the extension is.
Right.
So for our purposes, though, we would like to write a Python source file, so I'm going to give this a name of test.py. Now, because, of course, Python files are associated so that when they are run, they'll launch the Python interpreter. They are also set up such that in the Windows context menu, if we right-click on the file, we're presented with an option to edit with idle. So if we click this, we once again get the shell loaded up, but we also get an editor opened immediately with that source file loaded. The source file is, of course, empty, so we see nothing in it, but you can see it has already established the file here. So now we don't have to go to make a new file and pick a location to save. It already exists, and it's open. So now that it's open, we can take a look at how we would go about using that, because the next thing you're going to want to do is write and run source code. So what we could do is write the very simple Hello World app and run it from within idle. And we can do that by simply running a print statement with the text Hello World. And now in order to run, we could go up to Run and press Run Module, but of course that's linked to the hotkey F5, so if we simply hit F5 from here, we'll be presented with a dialog asking if we would like to save, because the source must be saved before it's invoked. So we'll hit OK to that, and then we see that we actually switch focus back over to the shell, and this is where we'll see the output. Unless we're writing a program that otherwise invokes dialogues or causes some other visual effect, the only thing we'll see is stuff outputted to the shell, meaning that stuff like standard out, whenever we print text, it's actually going to go to this shell as opposed to a new console window as it would if you were to run it directly within Windows. To give an example of that, I could go back to our Python projects folder and simply double-click the test.py file, and you may see very briefly a window flicker up.
Mm-hmm.
We'd have to do something to hold up execution to show it for longer, but of course if you run it from within Windows, you'll be presented with a Windows console window, whereas when editing in idle, all of our output goes to the Python shell.
Gotcha.
And let's see, a few things I want to address before we go on from here is a few preferences that I like to set up. As I had mentioned earlier, I do prefer to have the editor given priority over the shell itself upon opening, and I'm also not very fond of always being presented with a dialog every single time I try to run. I would rather it just, upon running, auto-save any changes that aren't already saved and run the program.
Because the saving is very important when you're about to run something, correct?
Right. Well, I mean, you'd have to, in order for it to run, it has to be saved to file first, which means if you were to run it without saving, you would technically be running the previous version before the save.
So obviously, all because you have code sitting right here in this open file, but it's not been saved out. That simply means that don't expect it to execute. It needs to be saved.
Exactly, because as we run these, we're running them from the file, which means if the changes have not been saved to file, we're not going to be running our changes.
So I'll switch out of student mode for just 1 second. And this really is a serious thing for those that are completely new to working with Python, because when you're working over inside of Visual Studio, you don't save. I mean, well, you should save all the time, but you don't necessarily save before you execute something. And you can execute, and everything builds, and there you go.
And you just said an interesting keyword there. In other languages, is a very common practice to build before running due to the non-interpreted nature of such languages. So now we're into an entirely new world where it's not just save before run, it's actually save so that we can build those changes so that we can run.
Yeah, so in this case here, I've actually seen students in the past working on scripts and executing and wondering why a line of code they changed is not showing up, and then they'll spend 20, 30 minutes trying to figure it out. It's just a matter of they need to save.
Because there are actually software development systems that will, if you have not saved changes, will actually save to a temp file behind the scenes silently. So if you're not used to these kind of editors, some will simply appear to be able to magically run what's on screen.
Right.
And they just have a silent temp file saved process in the background.
Which will just pretend it just works.
And here in idle, just being out and open with you saying that, look, okay, you have a source file, we're not going to do any magic behind the scenes. Do you want to save this so you run your newest stuff?
Exactly.
And now to expedite this process, since I'm very much in the habit of just running, and so that means I end up catching myself with that dialogue quite a bit.
Mm-hmm.
So what I like to do is jump into the options. If we go to Configure Idle, we have a fourth tab over on the right under General, and we have the ability to autosave, or basically we have the ability to prompt or not prompt. If we set it to no prompt, then that will tell it to autosave. So the action of running will first check. If it's not saved, it'll save it automatically and then run it.
Very nice.
So that way you're not prompted with a fairly obvious dialogue saying, like, yes, I really do want to run my program.
Gotcha.
Another thing I'll do while we're in the preferences is I'll change my startup preferences to open an editor window, and this will simply make a lot of the examples we're going to write a lot easier to do. What I mean by that is I'll very often be writing simple single file programs, and so opening an editor window simply allows us to get to the code more quickly.
Okay.
Once again, just a personal preference in that case. So we can hit OK to these changes. And just to make sure that they're working, what I could do is close out of idle. So I'll close this, make sure we close down the shell window as well. So we have all of idle closed down. Now if we right-click on our source file, say Edit with idle, we're presented with the code. We don't even see a shell window yet. We actually have to run the program to see the shell window. And also, if I go in and make some change, like I put the character 2 in front of everything, notice that we have a little asterisk around the file name up at the top here in idle, indicating that the source file is now dirty or unsaved. There are unsaved changes. If we hit F5, we immediately save file and run and see the output.
Outstanding.
Simply streamlines the workflow. So, and that's really the basics of the editor and the shell window itself. There are a few more things that I want to point out about the shell window. You'll notice that I've actually opened and closed it a few different times here. And if you want to invoke it without actually running your program, you just want to get back to a shell window, that's actually an option under Run. We can bring the shell open without running anything. And another interesting thing is the way exiting works. If we go into the Python shell under File, we see we have two options that seem kind of ambiguous. We have close and exit, which I'm sure there's applications where both of these have been used to mean closing the application. We even see the shortcut Alt F4, which is generally the application close shortcut under Windows, being listed as closed. But there is a difference. Close closes the Python shell window and leaves any editors open. The exit option exits all of idle, including your editor. So you want to be careful which one of those you use if you go to close the shell window. One final thing that's helpful when you're testing things quickly is if you want to maximize your editor and your shell window, or just your editor, you'll notice that opening the shell window, or even better, if you're testing your code and running often, if we hit F5 to run, now our focus is over here in the shell. If we only wanted to use the shell to give output, we want to get back to our code to edit, we of course have to go up and close the shell and be careful not to close everything. There is a shortcut, Control-D, which will close only the shell, so that way we can run, see our output, Control-D, and now we're back to editing without having to move the mouse around or hunt for buttons.
Gotcha.
So that can be very helpful. One final thing I would like to point out about the Python shell window is just like using the interactive interpreter at the command line, you can do all of the same type functionality, meaning we can run print statements right here inside of the shell window and everything is perfectly interactive. Now, of course, in the console window, it's kind of following the rules of the Windows console in that the up arrow key will retrieve previous commands, which means if I were at the console version of the Python shell, I could hit the up arrow and we would see print hello world reappear. If I hit the up arrow here, we're actually navigating the cursor inside of the Python shell, which may be a little bit startling if you're not used to the shell at first. It does allow you to recall by navigating to a previous command, so I've actually moved the cursor up to the print hello line, and if we bring that in, it will actually bring it back up. If you want to do a more classic style walk through previous and next commands, you can use Alt-P and Alt-N. Alt-P will iterate through previous commands, and Alt-N will iterate through next. Nice. Of course, I would need more than one to really prove this, so we could say something like x plus 2, and that's an expression by itself, so it's 2 plus 2, which will have a result if I type everything. Just coming up with ideas off the top of my head, but now we can go up a few lines, so Alt-P will have a few different things. Nice. Alt-N will have a few different things. If you continue to press it, it will simply cycle.
Okay.
So that's useful. If you want to get that kind of walking functionality, you can do it. It's just Alt-P and Alt-N instead of up and down.
Okay.
Now, with that, I think that's all I wanted to cover in the shell window. Let me just point out a few things inside of the editor itself. Some of the more what I would consider IDE-style features of the editor. And one of those is the autocomplete window. The autocomplete window is a small window which will pop up to show you possible attributes to something, where something is generally some kind of object, meaning a class that has members or even just the functions of a built-in class. This can be useful if, for example, you're trying to work with strings and you know in the back of your mind that there are string operations, there are functions that go with strings, like things like capitalizing, uppercase, different splitting operations. But let's say you can't remember exactly what they are. Well, the autocomplete window is very helpful because it will list all of them for you. And we can gain access to the autocomplete window by hitting the dot separator and either waiting a few seconds, actually 2 by default, or by hitting tab to bring it up immediately. I'm actually going to de-maximize this window just so we can see the entire autocomplete window.
De-maximize, I like that. That's a new way of addressing restore.
I guess you could say restore if you really wanted to be technical about it, but if you enjoy it,
no, that's cool. De-maximizing, all right.
Good stuff. But you'll also note that I'm using a literal string because I'll get to another interesting point here in a minute. What I'm looking at here, of course, is a literal string. So if we hit dot, wait 2 seconds, we get this list showing that we have things like count, decode, find, index, a whole lot of methods that are part of strings. Now, generally, you will have data stored within identifiers, or in this case, variables, which meant if we did something like text equals cat, we have now made a variable pointing at a string. So if later in code we want to say, all right, well, we're going to do something with the string held in text, so text dot. We wait, some more. We hit tab a few times to try to make the pop-up show immediately because tab is a way of making the autocomplete window show more quickly. If we hit dot tab, we immediately get the window without
Didn't have to wait the full 2 seconds.
Exactly. But we're looking at text here. We're going, all right, text dot, no autocomplete window. Tab gave a literal tab. It didn't show any autocomplete window. The reason being is that the autocomplete window has to know the type of the thing it's looking at in order to show any possible attributes it might have. Of course, the way Python works, it's dynamically typed, and that means that the identifier, in this case the variable, has no type information associated with it. It's the data it contains that defines its type. And at the moment, because we have not yet run, text doesn't actually contain cat yet. We have just written this in the source file. We have not run the code yet. And so if we were to run the code and then go back to our code here, we can type in text dot, wait a second, and there we get the pop-up.
Very nice.
So
the bottom line is before you actually execute it, it's just text right now sitting there in an editor. Exactly.
And the interesting thing is that once you have run it, the way idle works is that all this information actually exists until the next run or reset of the shell itself. So technically all that has been run still exists in memory. Idle is actually set up to behave more like the interactive prompt than a standard text editor.
Okay.
And that it's not a complete re-invoking from fresh. We're actually working on something that has just been run. So everything that's run is actually still resident in memory. I can actually prove this by bringing up the shell and running the directory function, dir function, at the global scope. And you can see all the everything defined here in scope, and one of those things is our text variable. We can actually see it defined out here. And that's, of course, why we can do text dot and get our autocomplete window.
Also why you can say print text right now, and you'll see that text still contains cat.
So print text from console, we see, yes, text is currently defined. We can use the delete command to get rid of text. And now if we rerun directory, we see that text is actually gone. That means we can't print text.
And this also means, if I'm correct, back over there in idle, that if you try using autocomplete, it doesn't exist.
Nothing. Even tabbing, still nothing.
Very nice.
So again, the autocomplete window is based on what is actually in existence in memory, what has actually been created or run, not based on the types, because, of course, the variables don't themselves have types.
Well, I have a question for you. What if... what if I'm a fan of the autocomplete and I don't want to have to hit tab all the time and I don't want to have to wait 2 seconds? Can I modify that 2-second delay?
Yes, as a matter of fact, I believe on mine it's running a little bit fast because I have indeed edited it. Because I've been saying, all right, we're going to wait 2 seconds, and the window has already loaded up.
Gotcha.
The reason for that is I have actually edited the configuration.
So the
for
2
that
seconds
value.
must have been driving you nuts.
And indeed it was.
Gotcha.
2 seconds is the default value for that pop-up.
Okay.
If you wish to go in and change that, you can get to it through the idle config files within the Python install directory. If we navigate over to the directory Python 2.5, where we had installed Python, we have a lib folder, and inside of here we have idle lib, And here we have all the source files to idle itself, which one can be interesting just to peruse in general. But if we scroll down, we have several definition files, and these are the config files for idle. One of these are the configuration for the extensions, and the autocomplete window is considered an extension. If we load this configuration file, and we scroll down to, where is it at? Looking, autocomplete.
Aha.
You can see my pop-up wait value is set to a value of 500. This value is set in milliseconds.
Yeah.
So 500 would give a value or a setting of 1/2 a second. By default, this would be set to 2000, giving 2 seconds, and that's why you would generally have the 2-second wait. So from here, you can set this to whatever you would like.
Okay.
And I'll leave it 2000 just for the time being. That way, we
or just close and don't save.
Either way. And yeah, I'll leave it at 500 just because I'm used to that setting. But again, if you want to set it to whatever you would like, this is the config file that controls it.
Well, you know, since I'm playing the role of student and we're just in here, great question. I see these pi files, and when you created that test file, you named it, of course, .py. I'm also looking at pyc files, and I see up under type that those are compiled Python files. Now, we had talked previously about Python, you know, being interpreted, and basically it's compiled to bytecode and then handled by a virtual machine. Is that what we're looking at right there with these .pyc files? Are these compiled bytecode files?
That's exactly what we're looking at. What has happened here is all of these source files have been used as modules. We can actually make the scenario ourselves. We'll do that when we get onto the lesson covering modules.
Okay.
But what has happened is basically some of these source files, or actually a lot of these source files, have been imported as modules as opposed to being run directly. Now, of course, in both cases, they do have to be compiled to bytecode prior to actually running within the Python runtime. Mm-hmm. But in the case of the module, Python has been set up so that it saves that compilation, that compiled bytecode to file, which makes any subsequent running faster.
Because it doesn't have to compile it.
Exactly. Now, it generally doesn't do this for source files that run directly, meaning that you run without using an import or aren't included using an import. That's why, if we look back up here in our directory, we have the test.py file. We have no pyc files.
Okay.
That's because we haven't used it as a module. Again, when we get into modules, we can set up a scenario where we import one of our code modules, and as we do that and run our program, you'll notice a pyc file gets generated and auto-dropped in place.
Okay. I was just curious while we were just sitting right there looking at it. Very nice. Is there anything else that you want to talk about in regards to the editor and idle as a whole?
I think there's one brief thing I want to touch on within idle, and then that's pretty much bringing us close to the end. What I do want to touch on is one last feature, and that is auto expand. Because we've been looking at the auto completion, which shows attributes. Basically, when you're actually looking at an object, you're curious to what things are available within it. That's where the autocomplete window is handy. If you're just trying to type out a word, let's say a function definition, a variable, or what have you, let's say that you know it exists and you've typed out enough of it to make it unique, and you would just like the editor to drop the rest of it in place for you. You can use that using auto expand, meaning if I were to type out the letters TE where I have a variable named text, you can hit Alt / and the rest of the word gets dropped in place. It looks rather trivial with this code in place here because we only have text and print, and they're both very short words. Mm-hmm. But if you start defining methods and classes, and you have things like call second recursive version of function, then we can call S and then autocomplete, or auto expand will speed the process up.
I see. And you said that was the Alt and / after
That's
typing
correct.
part of it?
Alt and / will run auto expand.
All right, very cool.
And again, just wanted to touch on that very briefly. But really, I think that's all I wanted to cover in this lesson here. Again, we were just looking at the idle IDE for Python, showing the way it's run, some of its components, meaning we were showing the fact that it's both an editor and a shell. It shares a lot of features back and forth between the editor and the shell, and that the shell itself gives syntax highlighting. It even gives the autocomplete extension. And we showed a little bit about some of the preferences, and working with new projects, new files from within idle.
Now, as we get deeper and deeper into this course, we'll start getting into debugging and stuff like that as well, right?
Right. We'll look at debugging, how to go about setting breakpoints. It's very likely we'll actually look at other IDEs as well, because certain IDEs have strengths for certain things, especially when you get into more complex scenarios. When you write applications that run continuously, maybe run in their own thread, maybe have their own window, maybe have their own application loop even.
Okay.
So we'll actually probably be looking at more than one IDE when we need to come up with different sets of requirements.
Fantastic. All right. Well, with that, thank you very much, Logan, and that is going to wrap up this video.